Having talked about incidence and prevalence rates, I now want to go on and talk about some common kinds of rates that you're going to see run into in the exam or indeed in other literature outside the exam. I want to make sure you understand how we calculate commonly used rates. So for example, what do we mean by a birth rate? Oh, well, that's easy. A birth rate is live births in a given period, a year usually, divided by the population in the same period. Live births divided by the population. Using our very simple metric, you remember this before, we have the event divided by people at risk. Wait a minute. That doesn't look right then, does it? Because, well, I for one am not at risk to give birth to anything. And so including me and all men in that general population doesn't make some sense. But leave it the way it is, because this is in fact how we do the birth rate. Although men are not at risk to give birth, it's easy to count the whole population, so we use the birth rate by that simple denominator, the total population. What makes more practical sense, however, is the fertility rate. The fertility rate is live births in a given period divided by women at risk to give live births. Traditionally, these are women in the age range of 15 to 44. Sometimes you're going to see, given our advances in medical technology, 15 to 49 as the denominator, but usually it's 15 to 44. Notice what the fertility rate gives us different than the birth rate. Birth rate is divided by the entire population, including people not at risk to give birth. Fertility rate uses the denominator much more practical utility, simply women who are most likely to be the ones giving birth. What is the mortality rate? Now that one's easy. It's death divided by people at risk for death. Who's at risk for death? Well, last time I checked, everybody. So death divided by the population as a whole. But there's particular kinds of mortality we want to focus on. Let's take a look now at the infant mortality rate. Well, infant mortality, we're talking about infant deaths, deaths in the first year of life, divided by all live births. Now, pause for a moment and understand what goes into this infant mortality rate. We're not tracking how long an infant lives after they're born. This is not following infants longitudinally and marking when they die or if they die in the first year. This is based on cross-sectional data. In short, in a given year, we count the total number of infant deaths, and in the same year, we count the total number of live births. Please notice, the infants we're counting as dying in this period might not be the same ones we're counting as being born in the period, because I could have been born last year but died in this year. Infant mortality rate is simply taking cross-sectional data in a given year, how many infants die versus how many live births do we have. Please notice also, stillbirths are not counted here, and we're not counting pregnancies. We're only counting something that's very reliable in our count, all live births. Now we can further subdivide the infant mortality rate into two distinctly different categories: neonatal mortality rate and post-neonatal mortality rate. Neonatal mortality rate is infant deaths in the first 28 days divided by all live births. That's fairly straightforward. The neonatal period, first 28 days. Post-neonatal mortality is infant deaths between 29 and 365 days, that is, leaving out that first 28 days, divided once again by all live births. Now wait a minute. Doesn't that look wrong to anybody? I mean, look at that again. Infant deaths from 29 days to 365 divided by live births. Shouldn't we be adjusting that live birth figure? Shouldn't we be saying live births minus the infants that died in the first 28 days? That would make rational, that would make mathematical sense, would it not? Right, but don't change that. Leave it the way it is here. The denominator is all live births. Even though that doesn't make real rational sense, the post-neonatal mortality rate does have all live births as the denominator, and for a very practical reason. We want to be able to add together the neonatal and the post-neonatal mortality rate easily in order to get the infant mortality rate. And the only way to do that easily is if they both keep the same denominator. So even though live births, all live births, doesn't make sense as the denominator for post-neonatal, leave it that way because it's in fact correct. That also tells you, very simply on your exam, if they give you the neonatal mortality rate and the post-neonatal mortality rate, and you're trying to get the infant mortality rate, it's easy. You take the two, you add them together, denominators are the same, and you can get the combined total, which is the infant mortality rate. But since we're talking about infant mortality, let's spend some time talking about infant mortality in the United States. Infant mortality rates in the United States for whites are roughly 6 per 1,000 live births. For African Americans, remember that is a little bit more than double that for whites. For Hispanics, it's about the same as for whites, an easy thing to remember. People from the island of Puerto Rico have an infant mortality rate somewhat higher than Hispanics overall. It's about 8 per 1,000 live births, but Hispanics and whites have a very similar infant mortality rate. The infant mortality rate overall is roughly 7 per 1,000 live births. In general, the infant mortality rate for all ethnic groups has been going down over the last 40 years, although in the last several years we found a flatlining and actually a slight upward tick for reasons that are much debated and beyond the scope of these lectures. What are the top 3 reasons for infant mortality in the United States? Number 1 reason overall is congenital anomalies, what we sometimes simply call birth defects. Number 2, low birth weight respiratory distress. Please note those are combined together into a single category. And although that might seem odd, with just a moment's reflection you can understand why we do that. Because low birth weight infants are very likely to have respiratory distress. And trying to separate out those categories which have a lot of overlap doesn't make any empirical sense, hence one category here. Notice SIDS, sudden infant death, is now number 3. Birth defects, low birth weight respiratory distress, SIDS, are the 1, 2, and 3 killers of infants in the U.S. That's the general pattern. Here's some wrinkles to that pattern. First, African Americans have the highest infant mortality rate due to low birth weight. The leading killer of African Americans, babies, is not congenital anomalies, it's low birth weight. Second, Native Americans have the highest rate of SIDS. Now please note, I did not say SIDS was the leading killer of Native American babies. I said they have the highest rate of SIDS of any other ethnic group. Who's more at risk for infant mortality in the United States? Well, if the mother's very young, the risk is very high. Teenage pregnancies come with high risk for infant mortality. If the mother is in poverty, the risk of infant mortality is very high. And especially if we're talking about single-parent families. Now, those categories often converge together. Many teenage mothers are single parents and they live in poverty. All those combined accentuates the chance for infant mortality, death in the first year of life. Since we're talking about teenage mothers, let's go on to talk about adolescent pregnancy. Roughly 1 million teenage girls become pregnant every year in the United States. That number's come down just a little bit over the last several years, but the round number, 1 million, is still a pretty good number to remember. Please note that's roughly 10% of all teenage girls. One of the reasons why the 1 million number has come down over the last several years is the number of teenage girls we have in the population has actually gone down a little bit as well. As they travel from age 15 to 19, roughly 1/3 of all teenage girls will have at least one unwanted pregnancy. So, when they have this pregnancy, what are the consequences? Well, half will actually have the child. Half will actually give birth to the child. 20% spontaneous abortion. They simply abort the way sometimes, unfortunately, happens with pregnancy. The remaining 30% will get an elective abortion. And as we've had a reduction in girls in the teenage years who become pregnant, we've also had a decline in the number of abortions in the United States over the last several years. Now, this next fact is interesting. Most adolescents, the majority that is, do not use contraception the first time they have intercourse. Adolescents in general don't use contraception, at least that's the balance, the norm, but they're least likely to use it the very first time they have intercourse. On subsequent occasions, they're actually more likely to use it. So let's get the fact in place. Adolescents tend to not use contraception, and we wish they would, of course. Now, if I survey adolescents and I ask, did you use some sort of contraception the last time you had intercourse? Overwhelmingly, they say yes. And by that, put those two facts together, you now know something about adolescents. Adolescents lie. What they say is one thing, what they do is something totally different. What are the consequences of adolescent pregnancy? Well, the key exam issue is for the mother, they drop out of school, may never work, they may not be able to finish their education. For the child, well, prematurity is much more likely. Neonatal deaths are much more common, as we alluded to earlier. There's also evidence of lower than average IQ. Now, I don't mean mental retardation per se, but I do mean lower than the average for the population, and delinquency rates are higher. Delinquency means criminal behavior, misconduct in young people. We don't want to call them criminals, so we call them delinquents instead. Talk about adolescent sexual behavior. Roughly, giving you round numbers here again, 80% of boys and 70% of girls are sexually active by age 18. Notice a few more boys, but there's a lot of sexual activity in girls as well. I'll also add for you that a recently completed survey says 95% of Americans have sex prior to marriage. The notion of waiting until marriage to have sex is certainly non-normative in the United States. Over 20% of sexually active girls become pregnant prior to age 20. This number is, of course, declining, and thankfully so. But the other key fact, 1 in every 5 adolescents will have an STD, a sexually transmitted disease. There are frankly more STDs in adolescents than any other age group. Why? Well, it's not simply a lack of contraception, it's that they have more sex. Adolescents are among the most sexually active of all the age groups in the United States, and so, not surprisingly, they have the highest rate of sexually transmitted disease. So let's see, true or false? The United States has the highest rate of infant mortality in the world. Well, that's false. I got that wrong. Let me try again. True or false? The United States has the lowest rate of infant mortality in the world. Well, that's false. Last time I checked, we were number 43 on the list. There's 42 other countries do a better job of saving their infants than we do. True or false? The United States is one of the lowest maternal mortality rates in the world. Well, that's true. We do a pretty good job of saving our mothers, but we don't do such a good job of saving our infants. Why? Well, I believe it's because the mothers vote and the infants don't. What do we mean by maternal mortality rate? Maternal mortality rate is computed by the simple ratio, maternal deaths in a given period, divided by live births in the same period. Please notice the maternal deaths and the live births may not be related to each other. It's once again cross-sectional data. Please also note that when we're talking about maternal mortality rate, the maternal deaths should be, well, not every pregnant woman that dies, but deaths that are at least tangentially related to being pregnant or delivering the child. Most important for you, though, out of all these rates we've talked about, are the last two, case fatality rate and proportionate mortality rate. Case fatality rate is simply deaths divided by people that have a disease. It's death given disease. Think about all the people in the world, or frankly in the U.S. that have a particular disease, what proportion of them die within a given year. That would be a case fatality rate. Proportionate mortality rate is something different. It's death from a given cause, let's say heart disease, divided by all deaths. The denominator here is all deaths. And so what you're getting in proportionate mortality rate is of all the people that died, what fraction, what proportion died of this particular cause. Case fatality rate, death divided by people with the disease. Proportionate mortality rate, death from a given cause divided by all deaths. We conclude with a simple summary table that lays out for you again, by way of contrast, some of these concepts we've been talking about. What is the crude mortality rate? That's easy. Death per population. The number of deaths divided by the total population. What is cause-specific mortality rate? That's fairly easy too. It's death from a given cause, think maybe heart disease, divided by the total population. We're talking about deaths due to some particular factor divided by the population as a whole. Case fatality rate is death from a given cause divided by number of people with that particular disease. It is once again death given disease. Proportionate mortality rate, just to reinforce, is death from a given cause, maybe cancer, divided by all deaths. If we're talking about proportionate mortality rate, we're talking about given all the deaths, think about a huge pie chart, what's the wedge due to this particular cause or this particular disease? So how might you have to use this content to answer a question for Step 2 CK? Well, this simple table presents some data to you, and then using this table you should be able to come up with the appropriate ratios according to the definitions that we've just learned. Now look, most people when this data table flashes up on the screen before you in the question, they have a panic response because there's a lot of numbers, a lot of lines, a lot of information. But the key to handling this question is not to focus on, quote, what did they give me? Instead, to focus on what do I need. Every good USMLE question gives you all the content you need to answer the question, but if it's written well, a whole bunch of content you don't need. So the mental discipline here is to not get bogged down in all the trivia, but to focus on just the numbers you need to answer the question. Hence, glance over the table, but now let's look at the actual questions. Question 14. The case fatality rate for disease A is what? case fatality rate. Well, let's see. That's the number of people that died from the disease divided by the people that have the disease, right? So how many deaths do we have? 77. Out of how many people with the disease? 153. The answer, of course, is E. Please notice the multipliers do not matter at all here. They're mere distractions, something that we're trying to get you to focus on that don't really change the answer here. There's only one possible answer. The way to get the answer, of course, is right numerator, right denominator, and then get out. 77 divided by 153. Number 15, the proportionate mortality rate for disease B. Proportionate mortality rate, that is, given all the people that died, how many died of this particular disease? How many total deaths do we have? 498. How many died of disease B? 98. Therefore, 98 divided by 498. The answer is D. Now look back again and notice how simple were those questions. Your job is to simply get the two numbers you need, construct the appropriate ratio, and then get out, and we'll move on to the next issue.